So, hey everybody, welcome to the session, Next Generation CDK Developer with Amazon Q Developer. Thank you for spending this hour with us. Really excited to talk to you about Amazon Q, the AWS CDK, and how we can accelerate that building process of those constructs. My name is Adam Keller. I am a senior technologist at AWS. I've been here for about 6.5 years, really doing all things modern application related, DevOps, infrastructure as code. And for the past couple of years, I've been focused on the CDK specifically. And Pahud, you want to say hello?
Hi, my name is Pahud Shea. I'm senior SA. I support AWS CDK team.
Awesome, thanks Pahud. Okay, so in this session, we're going to start by just talking a little bit about some of the problems we've seen over the years and frankly, some of the challenges we deal with today. We'll talk through the CDK, so there are some folks here that may not be intimately familiar with all of the great things that the CDK has to offer. So we'll do a primer on why the CDK is so great. We'll talk about the benefits of building abstractions through constructs. And then probably, the reason why you're here is we're going to talk about how you can use Amazon Q and that generative AI coding companion, as I like to say, to help you build faster, move faster, and really focus on what it is you need to focus on. And then Pahud has a really awesome demo, which frankly is way better than anything I'm going to say today, because it's a real world demo that's going to show you how things work. So everyone here has, I am sure, built something in AWS, whether you build a lot, you build a little. And there's quite a few challenges when you're building. Whether you're using infrastructure as code, you're building in the console, you're writing your own sort of automation. You have to keep up with services, keep up with features. And as you're keeping up with new technologies, there's an on-ramp. You may very well have a use case where you're very familiar with using a particular container technology, and then something new comes out, and now you have to figure that out, learn it, and there's an on-ramp. A new infrastructure as code language, there's an on-ramp. So it's a constant evolving ecosystem. Things are changing all the time. So it can be challenging to keep up with these things. And then on top of this, as we're running our applications, as we're running our workloads, in the real world, in the cloud, in AWS, things are going to go wrong. We're not perfect. We make mistakes, and we have to troubleshoot. And oftentimes that troubleshooting can be time consuming. We try to write tests, and if you're like me, you would agree that unit testing and local testing is super important. Having great documentation is important. But if you're like me, maybe you're a little lazy and you don't always do it. And it's hard to keep up with. So trying to keep up with all of these things while trying to learn new services, learn new tools, it can be quite a challenge. And what we've seen over the years, I have been working in AWS, like building in AWS for the past 10 plus years. And when we first started, and even before AWS, when we would build things, there was oftentimes whether that's you're racking and stacking a server, you go in the AWS console, you click to build what you need. Look, there's no judgment. We all have to get what we need to get done, right? But we quickly found that building in the console, manually building things was challenging, and ultimately there were a lot of failure points, a lot of points of contention, and oftentimes we didn't keep up with documentation. So, maybe someone that built that service or built that particular functionality, they've moved on to the company, and now you're left to figure out how the heck this thing works. So we started to add some scripting into the mix, and maybe we were building infrastructure as code using Python, maybe Bash. We love Bash or PowerShell. But again, maintaining and managing infrastructure or cloud resources, as I like to say, it can become challenging when you need to manage those CRUD operations. So I'm creating, but maybe I need to update. So item potency is very important, and to manage that in your own sort of scripting language, your own code, is very hard. And this is where the birth of infrastructure as code came. And this is where tools like AWS CloudFormation, Terraform, made our lives a whole lot easier, because we could simply declare our desired state of what we want to build and what we want to see in our environment. And it was the job of that infrastructure as code engine like CloudFormation to handle those CRUD operations, to create the resources, modify them, So I didn't have to think about all of that logic. I'm just declaring my desired state, and I'm good to go. So if you've made it here, you're doing a great job. And frankly, if you have, you're all doing a great job anyways. But if you made it here and you're using infrastructure as code, you're doing the right thing. You're saving time, you have your desired state defined in code, hopefully you're using version control, and you have a good tracking and good history of those changes that have been made to your environments. That said, when you build your own infrastructure as code using CloudFormation or something like Terraform, oftentimes you have to know all of the nuts and bolts of what you're building. So knowing that boilerplate logic, building that VPC from the ground up, creating those route tables, making sure you're in the right availability zones, NAT gateways, internet gateways, it can become cumbersome and time consuming. And we don't always want to build those things if we don't have to. We don't want to have to think at that level if we don't necessarily need to. And this is where we saw the birth of tools that have abstractions built in, like the AWS Cloud Development Kit. So the AWS CDK is really where we started to see this movement towards not only am I able to define my infrastructure as code using a programming language, but there's these powerful abstractions built into the tools that allow me to just focus on what it is I want to focus on, and I can leverage these intent-based APIs, these helper methods that make my life a whole lot easier, so I don't necessarily have to author IAM policies or create all of the entire VPC on my own, and I can maybe build on top of that later when I need to. That said, in a real-world environment, you're doing all of these things. That's the real world. And there's probably someone at your office right now or at home, they're building something manually in the console. There's someone that's writing scripts. Scripting is a great thing when you want to automate one-off tasks. Maybe you want to empty an S3 bucket every day because you use it for testing, but you don't want to pay for it when you're done. And then same goes with infrastructure as code, very important. Amazon Q can help you in every single stage of your building and development process when you're building in AWS. So whether that's the console, your IDE, you can leverage a generative AI coding assistant to help you along the way. And we'll get into that in just a moment. So when I asked y'all earlier, I said, how many here are familiar with the CDK, who's used the CDK? There's a good mix of folks that use it regularly and some that are new. So I'm going to talk a little bit just about what the CDK is. And so the AWS CDK, or the Cloud Development Kit, it's an open source software development framework that enables developers or builders to define your infrastructure as code using a general programming language. So whether that's Python, TypeScript, JavaScript, Java, .NET, C#, Go, you have the ability to choose the language that you want to author your infrastructure as code in. And oftentimes when I talk to people, they look at that and they think, that's awesome. That to me is the main selling point of the CDK. But actually, in my opinion, the real true power of the CDK lies in those abstractions, which we call constructs. And I'll dive into constructs here in just a moment. But these constructs offer intent-based APIs. They're very readable and easy to understand with these helper methods that make it a lot easier when you're building to just use simple words and phrases to build the things that you need to build. So the CDK uses CloudFormation for state management. So we're not reinventing the wheel with infrastructure as code state management. We use CloudFormation. It's tried, it's true, it does a great job. So the CDK simply allows you to write your code, your infrastructure as code using a programming language. It will then transpile that to CloudFormation, and then CloudFormation handles all those CRUD operations for you. And as I mentioned, those intent-based APIs and abstractions, these save you a lot of time because authoring IAM policies. Again, if you're like me, you know that you want to build an IAM policy that's going to be least privilege and that's going to do the right thing, but boy, is it a pain, right? Writing IAM policies can be a real pain. So instead of me having to author an IAM policy, attach it to the role, make sure that the role has the proper principal that can assume that role, I can just use a grant method in the CDK that handles all that for me. On top of that, you can also use the CDK to build your application assets. So one practice that I'm very fond of is coupling your infrastructure as code with your application code, especially when you're deploying serverless applications, containerized applications like on Amazon ECS, AWS Fargate, because everything lives in one place. I don't have to go find the other repo. I don't have to manage two build processes. The CDK can actually handle the building of your application asset, storing of that asset, and then making sure that the compute you deploy runs off of that latest version of that asset. On top of that, security is very important. I'm a big fan of policy as code. So with the CDK, relatively recently, over the past year and a half, we've released some pretty cool features with the CDK that allow you to shift that governance and shift that policy left to the developer's workstation or to the builder's workstation. And as you're writing your CDK code, you can actually run policy as code against it. And you can very quickly know if you're out of compliance or you're doing things that don't fall within a best practice. So there's two ways to do that. There's CDK NAG, which is a really popular open source tool, or there's the policy at synth time, which allows you to integrate CFN guard with your CDK apps. And the CDK is very community driven. We have an amazing community with the CDK. There's a Slack channel, CDK Dev. We have folks from outside AWS that contribute to the core library, and it's a very passionate community. So if the CDK is something you're passionate about, you have questions, you want to bounce ideas off of someone, head to the Slack channel, reach out. The community is very welcoming and very accepting, and we'd love to see you there and hear what you're building and so on. Okay, so I mentioned the abstractions. In the CDK world, when we talk about abstractions, these are called constructs. And there's various levels of constructs that offer various levels of abstraction. So the first is going to be our level 1 constructs. These map directly to CloudFormation, and oftentimes you see folks using level 1 constructs when it's one of two use cases. Number one, currently there isn't an L2 construct or a higher level abstraction available for that particular resource. Or number two, the team building constructs wants to have full control, like I mentioned earlier. They want to have that granular control and create everything from the ground up and really make sure that they create that thing end to end and own it. So those are the two use cases. Whenever a new resource is launched in CloudFormation, you will see it in the CDK as an L1 construct within a few days. But then we have our most popular construct, which is our level 2. Now, our level 2 constructs, these are curated and built by the CDK team. These offer these intent-based APIs and these abstractions that allow you to move faster as you're building so you don't have to think about the boilerplate that takes time. So in this example here, you can see I'm creating a DynamoDB table. I'm creating a Lambda function. I'm creating an S3 bucket. Now, if you're authoring this outside of CDK, you're going to have to create an IAM role. You're going to have to assign that role to that Lambda function. And then if I want my Lambda function to access an S3 bucket or that DynamoDB table, I have to create those IAM policies. I have to attach them to the role, and I have to make sure I'm doing it all the right way. Well, instead, with the CDK, we have these helper methods. So you can see here, we're calling, on this bucket object we're creating, we're calling grant read. And we pass in the Lambda function object. So that's one line of code that's authoring a policy and attaching it to that role for me. I didn't have to do anything except say grant read. And the same goes with DynamoDB. I'm just passing my Lambda function object, and CDK is handling the creation of those IAM policies and attaching them to the right roles and so on. So by far, L2 constructs are our most popular. And then we have the level 3 constructs. When you look at level 3 constructs, these are going to be your patterns. These are very opinionated. Oftentimes, you'll see platform teams building L3 constructs because it consists of a pattern. In this example here, we have the application load balanced Fargate service pattern. This L3 lives in the CDK core library, but this right here can generate around 800 plus lines of CloudFormation code. So in this case, I'm just passing in 5-6 lines of code, and it's very opinionated, and it can build a VPC for me. It's going to build the container image. It's going to build the task definition, load balancer, target group, all those things for me. I don't have to think about it. This is really good for testing. It's really good for trying out new use cases. But there is one caveat with L3 constructs that everyone should know is it can be difficult to break out of an L3 construct when you need to. Because they're so opinionated, it sometimes can be challenging to break out and do things that you want to do that don't fall within that pattern. And oftentimes what you see folks doing, if they are leveraging an L3 like this, is they have to use more advanced CDK functionality like escape hatches, which it could be a little more challenging. So definitely L3 constructs are for those use cases that you're very opinionated and you know what you want to build. So there's a couple different ways that we see customers building constructs out in the wild. We have our platform teams. So platform, engineering, this is all the rage these days. And, the platform teams are building these central libraries of constructs. And they build these libraries to enable their development teams or maybe their other infrastructure teams to build. But all of the opinion and all of the guardrails that the platform team wants to enforce, they build into those constructs. And then they vend those across the organization. Teams download those libraries and deploy. Another common practice we see, and of course, by the way, do not repeat yourself, dry patterns. So there may be like a mono repo, or you have a lot of, you're building an application, a CDK app that has 25 Lambda functions. You probably want to create a generic construct in that library and then just use that so you don't have to keep writing the same code over and over. And then the other use case is when there is no L2 construct available, but you want to build an L2 construct. So that's what we see in the field. Now, every choice you make, there's always going to be some sort of consequence with the choice, right? We have to kind of understand that there's always going to be a limitation or something that can get in your way. So depending on the path you choose, will kind of determine what that level of developer autonomy is. So if you're building those patterns, you want to own those centrally. Generally, the developers are going to have less autonomy. They have to fall within your standards. If they can't break out of those constructs, it's up to that platform team to keep rebuilding. This can be challenging. It's kind of like a treadmill. You're constantly trying to keep up with developers. And then there's the option of just extending constructs. So extending an L2, like the S3 bucket construct, I can extend that construct and just simply enforce that every time someone uses our S3 construct library, or our S3 bucket construct, that encryption is always going to be enforced. I can override those things just by extending an L2. This offers developers more autonomy. They can build leveraging the native functions of that construct. You're just enforcing your rules through that extension. And then there's policy as code. You can just let the developers run, let them do what they want to do, and then just force policy as code into that CDK deployment process and that building process. So you're now just creating rules that determine what those guardrails are for those developers. So as we can see, constructs can be time consuming. It can be challenging. If you're new to building constructs, there's an on-ramp. If you are, this is something that you want to keep building and maintaining, there are challenges there. And this is where Amazon Q can really help us. So Amazon Q Developer, I like to talk about it as your generative AI coding companion. And what's nice about Amazon Q Developer is it can live with you, whether Amazon Q is in the console, so you can be in the AWS console, ask questions about what you're seeing and working on in the console, or in your IDE. And leveraging this generative AI coding companion will help you move faster. So let's get right to it. Let's talk about the construct development workflow with Amazon Q. So what we have here is our very common software development lifecycle. And I think this applies to infrastructure building. It really applies to anything you're doing when you're building, architecting, designing in the cloud. So we have these phases. We have the plan phase where we need to figure out what is it we want to build? What services are we going to use? And this requires reading documentation, planning, preparing, architecting, diagramming, figure out what exactly it is that you want to build to make sure you're making a good choice to solve the business problems. Then you got to build it. And you have to write that code. You have to manage that infrastructure, and then you have to test it and make sure that it works as you expect, that your desired state's being met. And then as you deploy things are going to break. Things aren't going to work the first time. You have to troubleshoot, work through that, and of course, it just never ends, right? The cycle just keeps going. So let's look at where Amazon Q can help us. Now, specifically what we're going to talk about is in the context of building constructs in the CDK. So that first phase is that plan phase. And when you're interacting with Amazon Q and you're interacting in the IDE, it's very important that you prepare the prompt. You have to make sure that you are very clear as to what it is you're trying to build. So in this case, if I am building an L2 construct from an L1, I'm going to have to be very clear with Amazon Q with exactly what I want to build. So how do I do that? Well, one, you feed it design guidelines. So the AWS CDK library has design guidelines. I'm going to feed that into Q. And I'm also then going to pass my own guidelines. So my company has determined that everything that stores data needs to be encrypted at rest. So I'm going to tell Amazon Q in my prompt, in that design guideline for my company, that we always have to encrypt everything at rest as well as in transit. So once you have those design guidelines, and then you want to bring some code examples. You want to give Q as much context as you can, and you want to be as clear as you can with what your desired end state is to get the best first response. And you share this in your local workspace, and when you're interacting with Q, Q can have the context of that workspace, and it can use that as it makes decisions to build those constructs for you. So at this point, we now have told Q, here's our design guidelines. Here's exactly what we want to build. Here's how we want to build it. We've been very clear. Now we're going to ask Q to generate that L2 or that new construct. I want to be very clear. It's not perfect. Amazon Q may not give you that right answer on the first try, and that's okay. But it's going to get you close. As long as you're giving it the right guidelines, it'll get you close. But there's a good chance you're going to have to iterate. And there's two ways you can interact with Q. You could just pass in the chat, you can say, here's my workspace. I want you to look at all these files, reference these files for design guidelines, and then do X, Y, Z. You can also leverage the Q dev agent, which will go and just build those resources for you, create all of that for you in a more autonomous way. And you simply you can approve or deny the results, but it'll essentially give you the progress as it's building. So again, once your resources are built, make sure you validate. You're going to go back and forth with Q a few times, and you'll see that in Pahood's demo. But just know it's not perfect, and there will be an iterative process to get you there. Now, once you have your code built, you're going to want to test it. So you're going to run a CDK diff. You're going to want to build a CDK app that uses that construct. And then you're going to probably want to deploy it to a test environment to see how it works. This is where Q can be really helpful as well. Okay, so we deployed it, but something's not working. I'm getting an error from CloudFormation that says I'm building a resource in the wrong way. That's okay. Let's go back to Amazon Q. Let's feed that error into Amazon Q, and it's going to help me figure out what the problem is. And again, it may not always get it right the first time, but it's there to help you. It's there to bounce ideas off of, to troubleshoot with, and so on. But then, as I mentioned earlier, I don't like writing unit tests, and I don't like writing documentation. I'm sorry. I should. I really should, but I don't. And it's a problem. I acknowledge that. I need to fix that. But maybe not anymore, because now I can use Amazon Q to ask it to write unit tests for me. So the benefit of using a programming language like JavaScript, TypeScript, or Python is I can just tell Q, I want you to write unit tests for me using this particular testing framework for my language. I want you to write documentation for me, and I want you to give me a README that has a getting started guide, maybe some inline documentation for my code, so I know exactly, when someone comes into my code base, they know what they're working with, and so on. We also did just announce today for Amazon Q Developer the test functionality as well as document functionality, so you can actually just directly call the test call within Q, and it will build those tests for you. And then the last thing is, I mentioned this earlier, I'm repeating myself, but the troubleshooting aspect. You're at some point, this is going to be running in the real world. So you're going to run into errors. Feed those errors into Amazon Q. Go back and forth and use it as like your rubber duck programmer. And just continue to ask those questions. And frankly, you can feed those errors in, and there's a good chance you're going to get the fix in that response. Remember earlier I mentioned new services come out. We're at reInvent. We've announced, a gajillion new services and new features and all these really cool things. But why not just ask Amazon Q when we want to implement something new we give it the context of maybe documentation for that service. Use it to help you build that, integrate that new service, to help give you some guidance and feedback as to how you can implement that in your new use case. And then of course for cost, security optimization, and performance, feed that data into Q and use that as your assistant. So basically the idea here is as you're building your constructs and as you go through your iterations, Q can help you every step of the way, whether it's building, planning, troubleshooting, and so on. So again, I'm done talking now. Now's the fun part. Pahud's going to come up and walk through a demo of how to do this in real time. So, Pahud.
Thank you, Adam. So in the next demo, I'm going to show you, and we are going to build something that does not exist. But I'm going to use Q to go through all the life cycle Adam just introduced, that leverage Q to generate CDK constructs for me. And in this demo, I'm going to build a L2 construct for OpenSearch serverless collection. So in case you miss it, if you use a Bedrock knowledge base, you definitely would provision your knowledge base with OpenSearch as a vector store or something. So that is super popular, but it does not exist as L2 at this moment. So what's happening now is that we are going to build it. So this is essentially an empty Git repository with just CDK init, nothing inside. It's just a skeleton, a skeleton repository. So let's get it started. Oh. Okay, so now we have an empty repository. So this is stack TypeScript and app TypeScript. Nothing inside. It's an empty repository. So what we really need to do is that we need to create a document directory and download the document. The first one is the design guideline from CDK official GitHub repository. It's maintained by CDK team. You can just click download from AWS CDK repository, just like this. It talks about everything about how CDK should be designed. And then we need another, and then we need to put a single alias name like this on the top of this document. And the second is your own private pattern. It could be your preference, your design patterns. It make it a markdown document to describe. For example, in this case, I have my pattern to describe what is L2 construct, what the L2 construct looks like. Like you have a simple code. For example, if I'm gonna build a full L2 construct, I first have to define its interface, like iFull, and what's inside that interface. And for some options, I prefer enum options. And for looking at the constructor, for example, full constructor, what would it look like? For example, I should have some method like from attributes, from name. And looking at its constructor, we need to create an L1 resource just within this constructor. And then we should expose some attributes like resource ARN, resource name as well. And in case you need to create some IAM role, if not defined, how to generate your IAM role with the minimal required permissions, and how to make it a private construct method. So put everything into that document, make it an alias name, my patterns. So now you have design guideline, you have my patterns, 2 documents only. Then it's time to talk to Amazon Q. So now my prompt would be, okay, at workspace, follow design guidelines and my patterns. Build an OpenSearch serverless collection for me as an L2 construct for OpenSearch serverless CFN collection, which is L1. So we are asking Q to build an L2 on top of L1. And then this is its initial generation, and it could be not perfect, but it's not a really big deal. You still have to look at it. So for example, looking at its first generation, it's actually building something that extends from construct, not really extends from CDK resource, which technically is not an L2, and it does not implement interface as well. So just take a very quick look. If you are not satisfied, okay, then it is your second prompt. Hey, the class should be called collection, which implements iCollection interface, right? Okay, so this means that, okay, you have to first define iCollection, then your construct should be implement that interface. So it's second attempt to generate the code. So as you see that it's pretty close to our expectation. And if you look at the type, it has the enum type as well. If you look at how it implement L2, it tends CDK resource and implements iCollection, which is awesome. And it has if you look at its constructor, it essentially creates the L1 in its constructor, and also comes with some method, helper method like grant read, grant write, all generated. I literally didn't write any code for it. It's just following my design guideline and my patterns. Then I just copy, paste into my IDE, and there could be some minor syntax error, but don't panic. You can just scroll down to the IDE and select those arrow, and then, for example, in this case, it's trying to use an enum type, which is not actually defined in this document. So we can just trigger, like we have select all and Command I to trigger the inline mode, asking Amazon Q to, hey, get it fixed. Get it fixed for this, fix this arrow, something like that. Then Amazon Q inline mode will scan this document and figure out what's going on here and get it fixed. For example, in this case, we are missing the enum type definition, and it will just get it fixed. It create the enum type for us on top of this document, which is awesome, right? And then we can just scroll down and see if there's anything missing. For example, okay, here we have the collection still having some issue. Don't panic, just copy all the error message from your VS Code and then trigger Command I, trigger the inline mode, and just copy paste that error message from VS Code to Amazon Q. Amazon Q will figure it out and get it fixed. So now I'm using the inline mode again to trigger the Amazon Q and get it fixed. So for some very minor syntax error or some minor error, just use the inline mode to trigger Q to get it fixed. And we scroll down a little bit, okay. Okay, so the inline mode will get it fixed. So make sure that there is no outstanding error in your VS Code. Then it should be good to move on to the AppTS, which is the entry point of our application. And we definitely need to get that library import correctly like this. So import collection from the stack like this. And then we need to create a stack that provisions the L2 resource for us. For example, my first attempt would be like this. Just select everything I probably don't need and trigger, Command I trigger the queue again to get it fixed for me. Okay, so I say redefine this stack in this file that created the collection resource for me, and hit enter. Okay, so Amazon Q would try to get it fixed when possible, but sometimes it probably does not do as good as you expect. But don't panic. For example, in this case, I'm gonna declare my stack like this. So for example, export class. My stack is tens, a general stack, and I'm gonna leave Amazon Q to auto-complete everything for me. So this is my declaration, auto-complete everything for me. So if you look at the auto-completion, it's the collection created in this my stack. And if we look at the collection type, it's okay. So then if we look at my stack, now we should new our my stack and make sure my stack is running in the CDK application, and all the properties would be auto completed, right? That is awesome. And I probably would like to create a collection for my vector store, so I can easily select the collection type. Because it's an enum, so I can select it's a vector store. The enum is auto-generated as well. So now I'm gonna try to deploy it because everything looks good from the IDE. So before the deployment, I need to authenticate myself. So I'm gonna run the AWS SSL login to authenticate myself with the identity center. So easy peasy, just AWS SSL login. And then before every deployment, I always run CDK diff to see what's going on there. So if you look at CDK diff, there's two resources being created. First one, security policies. Second one is the collection. Security policy is a dependent resource from the collection, but Amazon Q will figure it out and ensure the dependency just within the L2 construct. So that policy will first created, followed by the real collection, which is awesome. I don't really care about that dependency. Amazon Q just take care of me. So if you really look into that deployment, the policy will first created, and then the collection. Now the deployment is good. So it's time to check it out from the console. We first go to the CloudFormation, make sure that everything is good, and then go to the OpenSearch console to go to the collection list and make sure our collection, okay, my collection is created. Then click into that resource. Make sure everything is good. But don't panic about those warnings because it's still very minimal implementation. We definitely need to iterate from there to define some very detailed like network access, data access configuration, which is optional. But for now, we just focus on the core function of this construct. Okay, then what we need else? We need document, we need tests, right? So it's time for another Q dev agent to help us. So now we open Amazon Q, and we are gonna say, hey, /dev, triggering the dev agent. I'm gonna say, hey, update the README markdown and generate all the unit tests for me. Generate the unit tests for the collection. And I just hit enter. Okay, so in case you miss it, so this morning we just had a new announcement for the QDev. So today we not only have /dev, but we also have /doc, /test, and /review, which is more powerful for tests and document generation. But for now, I just use /dev to help me generate the code. But so what's happening here is that the dev agent will review your code base and see what you have now. So for now, I have a collection L2 construct, which has very well defined. That's awesome. And in my app TS, I have my stack defined, which would create the collection resource for me. So the dev agent would review all the existing code and document within your repository and trying to propose a plan to address your intention or concern. Like, so in this case, you can see that what's going on here. The dev agent has reviewed my existing README, which is a very dummy README file, and review my stack TS in my library as well. And it's trying to update my README, so you can see that README has been changed. And then will start generating all the unit tests for that L2 constructs for me. And this could take a while, like a few minutes, but just be patient, because this would ensure that the document is well generated and tests will be covered. Okay, so we talk about different patterns here for Q. We talk about the chat, we talk about the chat, which would have immediately response. So when we first generate the code, we prepare the document and trigger the check to with an prompt to trigger the generation. And for some immediately inline error in the IDE, we use the inline mode, Command I, to trigger the inline mode to get it fixed as well. But for some very complicated requirements, such as document generation, or for the unit test generation, we use the dev agent or /doc/test/ something like that to help us to generate the assets for us. Okay, and this could take a while. Okay, so after this generation, we should be able to see the unit tests is all generated. Yeah, and we can see the manifest list. Like for example, our README. Click the README, we can see a very great diff to see what has changed. The red README is the original version, and the green is what's been added into the version. And we can see that all the features, usage, sample, and all the method and how to development from there. It's pretty much like the CDK official style document. And if we look at the tests, we are actually building the collection only, and it has proposed some test case for that collection, and that is actually a jest style unit tests for us, which follow the CDK best practice. And then we can just simply click accept code, and that document and all the unit tests will merge back into my IDE. Then I can just scroll down to see if everything looks good to me. For example, I still have to go to the unit tests and see is there any error happening here in my IDE. For example, we see some tiny import problem here, and we need to we can scroll down to see using the Command I to simply get it fixed. For example, this is an import problem. We need the AWS IAM, but it's trying to import using CDK AWS IAM. But if we try to use the Command I to get it fixed, sometimes it probably not work as good as we expect. But it's not really a big deal. It's just the import issue. We can still import that like this. For me, like for example, import IAM, I can just use AWS IAM as IAM to get it correctly import and get it fixed like that. And yeah, if everything looks good, we can just run young test. And this will trigger the test with all the tests queue generated. And then we can see what's going on here. The tests, because Amazon Q would not run the test for you, so somehow you still have to run it yourself. And it is very likely that one or two tests could fail for some reason. And at this point, we have seen some developer tend to just copy everything from the error message and copy back to Amazon Q to, hey, Q, can you get me fixed like that? But for me, I would prefer to look really into the unit test. You have to know what you are testing, right? And for some very tiny issue like this, for example, it's trying to test all the privileges like like for the open source serverless, the create and update and delete privilege, we probably don't need to test that at this moment. We just focus on very core function for now. So just simplify it, simplify your test. Realize what you are testing, try to get it fixed when possible. For example, in this case, I'm gonna get it fixed and run again. Then, okay, all tests passed. So now we have a really great README document about the usage, about its API reference, about its sample, and now we have basic unit tests covering the core functionalities. I think it's pretty good now, and it's actually a deployable application, deployable L2 constructs following the CDK design guidelines, and as well as our opinionated preference as well. So I think it's pretty interesting to get it started from there. And I literally didn't write any code of it, and that is auto-generated from Amazon Q. Okay.
It's still really important to know what you're building, right? We want to make sure that Q is there to help us, but as you could see, there were times where we had to go back and forth, and we have to iterate. It's not going to be perfect the first time, so it is important that you understand the CDK, you learn the concepts, but you can use Q to accelerate that development. I mean, it's pretty remarkable when you think, and that was maybe 20 minutes, if that Pahud went from, and it was a recorded video, but there was no cuts, nothing like that. Pahud went from nothing to a working L2 construct that based off of an L1, and it had tests built in, and it had documentation ready to go. So just know that it's a process you have to work through, but as you can see, it helped Pahud get there a lot faster. So a couple of things I want to point out. First of all, please go out there and build constructs, build on the CDK, and as I mentioned, the community is strong, and the community is big. There's a lot of folks out there that want to talk about the CDK, that want to help. There's also the CDK team at AWS. We want to help. So if you run into issues, you want to see a new feature, go to the CDK GitHub repo, submit an issue, tell us what you're dealing with. We want to see you run successfully on AWS. We want to see you have a good experience on CDK, and we're continuing to iterate to make it better. But in the meantime, two things from Pahud's demo that I think will be really helpful. Number one, that repo, which I don't know if we launched it yet, but we're going to launch it very soon after this talk. That repo has his guidelines, so use that to build your guidelines. Look at that as kind of that North Star is how you want to kind of define the guidelines for your use case. And number two, the CDK GitHub repo, grab the guidelines from there, because those design guidelines are maintained and managed by the CDK team, who is building these things on a daily basis, who knows the CDK very well. And then there's a couple ways you can publish them. So again, you can contribute to the main core AWS CDK library, but if you're just testing out a new construct and you want to kind of just beta test a new L2 and see how the community, how they take it, you can publish that to the construct hub. And that's just at constructs.dev. You can see all the community created constructs and use that as a way to get feedback from the community as you build. And then of course, if you want to leverage constructs outside of the AWS CDK library, there's the AWS Solutions constructs, which are built by solutions architects in AWS. They're the folks out there in the field talking to customers all the time, so they build constructs and patterns that they see customers using. And I didn't put it up here, but there's also the Open Construct Foundation. This is a foundation separate from AWS that is passionate about the CDK. They have some CDK leaders running it, and they have a construct library. And I'm sorry I didn't include that in here, but just look up the Open Construct Foundation, and wonderful group of people, again, community-led, doing really great things for the CDK. And then please share what you build with us. So these are our social media profiles. As you can see, I went a little nuts with the QR codes. I apologize. But please reach out. Like if you build something, reach out on for me, it's Blue Sky. Pahud's also on Blue Sky. I didn't put it up there, but reach out on X for Pahud. We have YouTube channels. So we have CDK Live, which is a YouTube channel where we're building and kind of going over basic and some kind of rudimentary concepts with the CDK. We haven't done anything as the second half of the year, but in 2025, we're going to start filming a lot more content, so keep an eye. Pahood's channel. Pahood puts out amazing content. Please follow Pahood. And that's it. Just thank you so much for being here. And that's it. So thanks again.
Thank you.